Hey guys, Mrs. Traber here. We're going to work through some examples on polynomial long division. So before we jump into a polynomial problem, we're going to do one with traditional division. So traditionally, if I had something like 138 divided by 4, if I was in this situation, I first wanted to change it over into looking like the long division form that we normally see. So it goes like this with the 4 on the outside as the divisor and the 138 on the inside, the dividend. And we'd ask ourselves, 4 goes into 1, how many times? It doesn't. So 4 goes into 13, how many times? It goes in 3 times, because 4 times 3 is 12. And then we'd subtract and get a 1. We will drop down our 8. 4 goes into 18 4 times, because 4 times 4 is 16. And we'd subtract off to get a 2 as our remainder. So I'd write my answer as 34 and 2/4, or 34 and 1/2, or 34.5. So a little bit of vocab for you here. I used some of it already, but this 4 is our divisor. The 138 is our dividend. The 34 is our quotient. And the 2 is our remainder. And so we're going to kind of use these words throughout the video, but there is the other way where we could drop the zeros in as the decimals and then keep going to get 0.5. But for the purpose of this video, we're going to do it with the remainder divided by the divisor, so that we can have a fraction out front, because we're going to end up doing this with polynomials, and it doesn't make any sense to use decimals where there's a polynomial. So let's try our first one. So our next one we'll do is got some polynomials in it, and I'll keep referring back to the problem above so we can see the steps as we're going. First off, let's set it up the same way. So like the 4 was on the outside, this x plus 2 is going to be on the outside. And try not to make that look like a square root if possible. It just looks kind of weird if you do that. All right, here we go. So x plus 2 goes into x squared minus 3x plus 4. There's my favorite math word, goes into. It's not really a word, but I like to think it is. So we've got x times what is x squared? I would need an x. X times x is x squared. So I'm going to put that x above the x column, just like over here when I was having 4 go into 13. In that case, 13 was like the 3 was the ones column. So I put my 3 above it because it was a 1 as well. So we're going to kind of play off that here. We're going to keep our degrees lined up. So just like I did here, 4 times 3 is 12. I'm going to do the same thing here. X times the quantity x plus 2 is, well, x times x is x squared. And x times 2 is 2x. And I lined those guys up with the degrees they belong with. Now here's what's next, is next we subtracted. We're going to do the same thing here. But just be careful, we're going to subtract the entire thing. So I'm going to put a parentheses around it so I make sure I subtract the whole thing. So x squared minus x squared goes away. Negative 3x minus 2x is negative 5x. And then just like here, we drop down our 8, we're going to drop down our plus 4. All right, now next, x goes into negative 5x, negative 5 times. So negative 5 times x is negative 5x. Negative 5 times 2 is negative 10. I can subtract this whole piece off. Negative 5x minus negative 5x goes away. 4 minus negative 10 is 14. And now notice, since my degree here is a constant, it's got degree 0, and my degree on my divisor was 1. Since the degree on the remainder at this point is lower than the degree of the divisor, we have to stop. There's no more going into it that I can do. X times nothing is 14. So we're all done there, and I can write my final answer like this. I have x minus 5 as my quotient, plus my remainder 14 over my original divisor, x plus 2. That's how our answers will look. Let's try another one. If I had x cubed, make that a cubed, x cubed minus 3x squared minus 7x plus 6 divided by x minus 4. I'd want to first set this guy on the outside as our divisor. And on the inside, we've got x cubed minus 3x squared minus 7x plus 6. And also notice in the last two examples I've done, the dividend was in standard form and also in descending degree, not missing anything. So x squared, x to the first, x to the 0, x cubed, x squared, x to the first, x to the 0. We aren't missing anything. In the next example I give you, we will be missing something. We'll have to make sure we have everything in play. So with this one, we can go ahead and jump in. X times what is x cubed? It's x squared. And then let's see, x squared times x is x cubed. X squared times negative 4 is negative 4x squared. And then I can subtract off that whole piece. Once you get back into the long division groove, it's kind of nice to just chug along and keep going there. X cubed minus x cubed goes away. Negative 3x squared minus negative 4x squared is like a plus, so that'd be plus x squared or just x squared. Drop down our next term. X times what is x squared? It is a positive x. X times x is x squared. X times negative 4 is negative 4x. And then I can subtract off that whole quantity. Negative 7x minus negative 4x is negative 3x. Drop down my last term. Last one. X times what is negative 3x? It's negative 3. Negative 3 times x is negative 3x. Negative 3 times negative 4 is positive 12. Subtract off that whole piece. Negative 3x minus negative 3x goes away. 6 minus 12 is negative 6. This is degree 0 and this is degree 1, so I'm all done. My final answer here then would be my quotient, x squared plus x minus 3 minus 6 over my original divisor, x minus 4. All right. I'll run through one where we are missing something that we have to fill in. So if I had a problem like this, I'm going to jump right to, I'll write it the original way first. X cubed minus 5x squared minus 2 divided by x minus 4. All right, let's see. Notice that we've got degree 3, degree 2, degree 0. So we're missing a degree 1 here. So when I write it out for my dividend, I need to put in an x term. And the only way to do that so that it doesn't change the problem is to use a 0x. So I'm going to put in that fake term there just so everything will line up nice. Otherwise, I won't have a spot for my x's and it won't work out as nice. So let's go ahead and jump into this problem. Other than that wrench I threw in there, it is the same as all the other ones. So we're going to jump in. We've got x times what is x cubed? It's x squared, so I'll put it above that term. X squared times x is x cubed. X squared times negative 4 is negative 4x squared. I can subtract off that whole piece. X cubed minus x cubed goes away. Negative 5x squared minus negative 4x squared is just negative x squared. I can drop down my 0x. X times what is negative x squared? We need a negative and another x, so minus x. And notice I'll stack that x right above my 0x that I put there, so there's a spot simply for that term. Negative x times x is negative x squared. Negative x times negative 4 is plus 4x. And then again, we'll subtract off that whole term. Negative x squared minus negative x squared goes away. 0 minus 4x is negative 4x. Drop down your last guy. X times what is negative 4x? I need a negative 4. Negative 4 times x is negative 4x. Negative 4 times negative 4 is positive 16. Subtract off that whole two terms. Those guys will go away, and here I'll be left with negative 18. So my final answer now is my quotient, x squared minus x minus 4 minus 18 over our divisor. All right. We're going to do one more example and then call it quits here. Hopefully this one will tie it all together on why in the world we're doing this in the first place. I'll kind of show you what the purpose of this is in this last one. So it'll be worth it. Our last one, I will set us up already in divisor form. So x squared plus 2, we're going to see how many times that goes into 3x cubed minus 5x squared plus 6x minus 10. So that's where we're going to start off. Like we've been doing, let's see, x squared goes into 3x cubed. How many times? I need a 3 and another x. So I need 3x. That's going to go way over here by the x's. So you will sometimes skip quite a few terms in the front. 3x times x squared is 3x cubed. 3x times 2 is 6x. That goes over here. So line your things up where they belong. You can subtract, and if you want to put a 0x squared in here, you can. I'll just leave it blank. 3x cubed minus 3x cubed goes away. Negative 5x squared minus nothing will drop down. 6x minus 6x also goes away. And then I'll drop down my minus 10. All right, x squared times what is negative 5x squared? I need negative 5. Negative 5 times x squared is negative 5x squared. And negative 5 times 2 is negative 10. You can see where this is going. When you subtract off, you get a remainder of 0. So in this case, I want to refer back to the problem that we did a while ago too. At the beginning of these notes, we did 138 goes into 4. Oh my gosh, I'm sorry. I wrote them backwards. How ridiculous. How about 4 goes into 138? And we ended up getting something that looked like this. So when we did this problem, we were trying to solve 138 divided by 4, and we came up with the answer 34.5. What we also came up with is that 4 times 34.5 equals 138. That's just the fact family of it all. So we can come up with the same situation here. We had our dividend divided by our divisor gave us our quotient. So therefore, our quotient times our divisor equals our dividend. If you follow along with me there, that was kind of a mess to say. But what I'm saying is, this gives us the fact that 3x minus 5, our quotient, times our divisor, x squared plus 2, equals our dividend, 3x cubed minus 5x squared plus 6x minus 10. So let me write these words under here. Quotient times divisor equals dividend. That is just basic division properties. But what's cool here is notice that this is in standard form, and this is in what we used to call intercept form. Think way back to when we did our notes on quadratics, and we had something that was like ax squared plus bx plus c equals 0, and we could graph this from quadratic form. And we had a different version that looked like this, x minus p times the quantity x minus q equals 0. And this one we could find the zeros. P was a 0 and q was a 0, also known as x-intercepts. So whereas we just got done learning about polynomials and end behavior, looking at the number out front, the leading coefficient, and the degree, we now know not only that from our standard form, but if we can put it into this format, we can also find our zeros. I could set this piece equal to 0 and this piece equal to 0 separately, and solve for where exactly this polynomial hits the x-axis. Let alone, I already know that it's got degree 3 and a positive leading coefficient, which I could tell because I kind of unfoiled this when I went through it. So hopefully all these pieces are going together for you, and this is all starting to come together. But there's 4 big examples of long divisions. I'm sorry that this is a long video, but it is called long division, so you get what you get. We will look next time at synthetic and see some examples of that as well. I will see you next time.